Hi, I am Kalyan Reddy Daida and I will be your instructor in this course, Terraform on Google Cloud, DevOps SRE, 30 real world demos. So here we are going to create 30 plus real world demos and in an incremental approach to build complex infra. And we are going to have step-by-step GitHub documentation for each and every demo in a detailed manner. So first thing is we are going to focus on creating or learning all the Terraform fundamentals. So we have close to 9 demos here wherein we are going to install the Terraform CLI and also install the gcloud CLI and whatever the CLI is required for us. So all those CLIs will install as part of demo 1. After that we will master the Terraform commands like Terraform init, validate, plan, apply. And after that we'll also learn about Terraform language basics, and then we will go and then learn about Meta-argument provider, input variables and output values, and also learn about Meta-argument count and also Terraform Datasources and Meta-argument for each, and also Terraform local values. So with these 9 demos we are going to focus on learning most of the Terraform fundamentals. So once these are completed, we will focus on implementing architectures in Terraform on Google Cloud, right, using various GCP services. So we'll start with creating the GCP managed instance groups. So we'll create instance templates, and using those instance templates we'll create the managed instance groups, and those things we are going to completely create it using Terraform. Later we will front that managed instance groups with regional application load balancer HTTP, and after that we will also solve a problem wherein if you disable a external IP for your VM instance, then how your VM instances need to access the internet and download the binaries. So for that you will implement CloudNAT and Cloud Router for MIG private IP, right? And then after that you will move on and then implement managed instance groups update policy. So how to update your application from version 1 to version 2. And once that is completed, we'll move on and then implement or use GCP certificate manager for our regional application load balancer to use self-signed SSL. And once that is completed, we will learn about cloud domains and then cloud DNS services and implement those things in Terraform, right, to generate the prod grade SSL with certificate manager with DNS authorization using cloud DNS, and also use either the registered domain from cloud domains or from any other external domain registers like AWS Route 53 or Namecheap or GoDaddy, and then implement a end-to-end implementation here. And after that we will implement a regional application load balancer context path based routing use case, and after that we'll also implement domain name based routing use case. So once those are completed, we'll focus on implementing custom header based routing use case in regional application load balancer. So once that is completed, we'll focus on implementing cloud logging and cloud monitoring. In cloud logging, we'll focus on how to send our application logs to cloud logging. The whole thing we are going to automate it with Terraform. And in cloud monitoring, how to create uptime checks, alert policies, and also send metrics, application metrics to our cloud monitoring. All those things we are going to implement in cloud monitoring. And after that, we'll also implement a DNS to DB use case with 6 practical demos. We'll start with creating a Cloud SQL MySQL database with public IP, and we will implement 2 demos using that Cloud SQL database. One is with DNS to DB with self-signed SSL with Cloud SQL public IP, and another one is DNS to DB with Cloud DNS plus Cloud SQL public IP. So here the difference here is in with self-signed, you are using the self-signed SSL. With Cloud DNS, you are using the production grade SSL. So for students who have the registered domains, right, in cloud domains or any other external domain registers, they can directly implement demo 24. And for students who don't have the registered domains available, they can use the demo 23 and then test the DNS to DB use case. So once that is done, we will go to the next level here, which is Cloud SQL with private IP. So here we are going to create private service connection from our customer VPC to the service producer VPC, which is nothing but Google Cloud's VPC, so that we get a private IP for our Cloud SQL, and that private IP we are going to implement. Using that private IP, again we are going to implement DNS to DB use case, and with self-sign and also with Cloud DNS. And if you want to use, if you have the registered domains, then obviously you can directly implement demo 27. If you don't have, you can implement demo 26 with Cloud SQL private IP. So once these are completed, we'll focus on learning about Terraform modules in two demos. One is using the Terraform modules from the Terraform public registry, and then implement it and then understand the Terraform module concept in detail. So once we understood that, we will go ahead and then build a Terraform custom module, right? And using that, how to build that custom module, we are going to learn in this demo. So once that is done, we are going to focus on implementing GCP DevOps for Terraform configs using Google Cloud Build and also GitHub. So this is going to be a very big section, and in a very detailed manner we have explained it. And after that, we'll also focus on creating the GCP Global Application Load Balancer demo, so which will load balance the traffic between two regions. We are going to cover 17 plus GCP services as part of this course, and many more sub-services covered under each of these services. So example, if you take Google Compute Engine, so we are going to learn about VM instances, managed instance groups, instance templates, health checks. So like this, multiple things are covered in Google Compute Engine. Or if you talk about cloud monitoring, so we'll talk about alert policies, we'll talk about uptime checks, and also application metrics, how we send it to cloud monitoring. So many things are involved. So like this, many sub-services under each service is covered. So all these things we have automated using Terraform. These things, right? So we are going to have a detailed GitHub step-by-step documentation. So for all these demos, and for each demo, right, when you see the Terraform manifest folder, which is the Terraform working directory, so you will have all the Terraform configurations ordered in a nicer way, so that you can easily understand them, read them, and troubleshoot them whenever you have an issue. So example, you have an issue with a firewall, so you can directly go to c4 firewall rules.tf and troubleshoot that issue. Or if you have an issue with the load balancer, you can go to C701 load balancer and then troubleshoot that. So every section or demo is well organized in GitHub and contains step-by-step documentation. And these are the GitHub repositories. This is the main GitHub repository where the code is present, and this second repository, whatever you are seeing, is used for GCP DevOps for Terraform configs using Cloud Build and then GitHub. So this completes the intro about what we are going to learn in this respective course. But most of my students ask for a detailed introduction. So you can skip here and move to the next lecture, or continue from here on and understand in detail with all the architecture diagrams what you are going to learn in detail. So earlier we have seen only on a high level what we are going to learn, but here we are going to see little detail. So what exactly is like? So first we will start with learning Terraform commands in a like what is init, what is validate, what is plan, what is apply, what is destroy. And once that is done, we will learn about Terraform language basics. So how many Terraform top level blocks are there, and what is the importance of it? Why do you use providers block, Terraform settings block, or input variables, output values, local values, or data sources, or modules? So we are going to learn the language basics in detail. We are going to cover it in 4.5 hours, so that lot of things are covered in these fundamental 9 demos, from installation of CLI tools to learning about Terraform local values, meta arguments, data sources, input variables, output values, and also meta argument provider, language basics. So like this, lot of things are covered here. So once the fundamentals are completed, we will start with implementing the regional application load balancer. So there we are going to learn about backend service, URL map, target HTTP proxy, and forwarding rule components in a load balancer, and automate them using Terraform. So as a user, when you access your load balancer IP address, the request will be sent from load balancer to your backend managed instance groups, right? And you'll have lot of VM instances present here. So for all those VM instances, traffic will be distributed from this load balancer. So this whole thing we are going to implement using Terraform. So once that is done, right, so we'll enter into a problem here. So what is that? So when external IPs are disabled for your VM instance, how will VM instance reach the external internet to download the software? Something like Nginx in your startup script, right? So, or in simple terms, how will you open an outbound internet connection for your VM instance, right? So we need to include CloudNet and Cloud Router resources in our Terraform configurations to implement that. So this part we are going to do in this respective demo. So here we'll add CloudNet and then Cloud Router. So once that is done, again we will enter into another problem. What is that? So how will you update applications hosted in GCP managed instance groups using Terraform? So how do you upgrade the V1 version of your application to V2 version using Terraform? So we will implement a update policy in our instance groups, and we'll also create a V2 version of our instance template and solve it. So that whole thing we are going to implement via Terraform and then learn it. So from there we'll move on to implementing SSL for our application, means like for our load balancer. So how do you implement self-signed SSL using certificate manager for a regional application load balancer? So we'll use the latest and greatest, which is certificate manager, and using that we will implement the self-signed SSL. So once that is done, we will move on to implement, right, production grade SSL certificate. So how do you implement production grade SSL using certificate manager for a GCP regional application load balancer with a registered domain present in GCP Cloud Domains service? So this we are going to implement as part of this respective demo. And here we are going to use production grade SSL certificates with cloud domains and then cloud DNS. So this is demo 1 from from registered domains perspective, right? Here cloud domains has the domain register, but there comes a picture where we don't have a domain in our Google Cloud Domains, but we have somewhere in AWS Route 53 or GoDaddy or Namecheap. Then if that is the case, then how do you implement this production grade SSL certificates using certificate manager? And also when your domain register is something else like AWS Route 53. So once this demo is implemented, we'll also implement some important concepts about load balancer. One is context path based routing. So which is when the request comes with /app1, right, as a context, it should be sent to one set of managed instance groups. And if the request comes with /app2, it should be sent to another set of managed instance groups. And when the request comes with root context, it should go to one set of managed instance group. So how you do that? Context path based routing. In load balancer, you will have a URL map, and there you need to do that. So this whole thing we are going to implement using Terraform, context path based routing. And next is we'll also have something called domain name based routing. So which is when your domain is app1.stacksimplify.com, request should go to app1 managed instance group related VM instances. And if your domain is app2.stacksimplify.com, then the request should go to app2 managed instance group VM instances. And if it is default.stacksimplify.com, it should go to any of the default managed instance group, whatever is configured. So how all these details you are going to configure in your load balancer URL map and implement it. So this also we are going to automate it using Terraform. And after that, we are also going to implement custom header based routing in our load balancer. So when you are using the APIs, right, so you will be sending lot of things via request and response in a request and response model using SOAP UI or RESTman. So when you call your URL with something like header app name equal to my app1, the request should go to app1 related managed instance group. So when you give the header name app name equal to my app2, the request should go to managed instance group app2. And if it is my app3 or any other value, it should go to a default managed instance group, whatever is configured. So like that, custom header based routing also we can implement in URL map, and that we have implemented it using Terraform. So once that is completed, we have implemented GCP cloud logging. So for the application we have installed on our VM instances, we are going to install the ops agent and also configure the config.yaml for ops agent to send the logs of that respective application to cloud logging. So once those logs are sent, we are going to verify those logs in the cloud logging. So that's what we are going to implement as part of cloud logging demo. And once that is done, we'll also implement cloud monitoring. So as part of that, we are going to create notification channels, uptime checks, alert policies, and also send our application related Nginx metrics to cloud monitoring. And in addition to that, so when we configure all these things, when something happens to our application, if it is down or anything, immediately it will send an email notification for us using the alert policy. So all those things we have configured as part of this cloud monitoring demo. And once that is completed, we'll move on with implementing or creating a Cloud SQL public IP with public IP. Cloud SQL with a public IP demo we are going to implement. And here we are going to introduce the concept called Terraform remote backends concept. So far in the previous demos, whatever we have used the local backend concept, which means our Terraform state file is stored locally in the Terraform working directory. But here it is going to store in the Google Cloud Storage bucket. So this concept we are going to introduce from this demo onwards. So we'll create a public IP, a Cloud SQL database with a public IP, and try to access with our Cloud Shell or our local terminal in our local desktop and test it. So once we learn about this Cloud SQL database, so we'll move on to the next step. Next step is learning about another important concept in Terraform, which is Terraform remote state data source. So here we are going to in project 2 we are going to access the project 1 related Terraform state file outputs from the project 1 we are going to access in project 2. So why do we need to do? Why? Because in project 1 you have your Cloud SQL database. Project 1 means Terraform project 1, and in Terraform project 2 you have all other resources. Example, your application is present here in managed instance groups in project 2. So if your application want to connect to the Cloud SQL database, it needs the IP address of your Cloud SQL database. So how you are going to get it? Using the Terraform remote state data source concept. So this concept we are going to introduce as part of these demos. And here again with Cloud SQL public IP we are going to do two demos. One is with self-signed SSL certificate manager, and here you can see communication is via internet to our Cloud SQL public IP. And this is for the students who doesn't have a registered domain, right? And we'll have one more demo, which is for the students who have a registered domain in cloud domains, or if they want, they can also use a registered domain from other domain registers and slightly change configs wherever needed to make it work. So here we will use the prod grade SSL, and we will implement a DNS to DB use case end to end here, again using the Cloud SQL public IP. So once this is done, right, so we'll move on to the next thing, which is GCP Cloud SQL private IP, right? So for this we are going to learn about private service connection, related concept, and then we are going to enable the private service connection between our VPC and also the service producer VPC network where Cloud SQL is present, and then enable a private communication between our VM instances present in our VPC to the Cloud SQL database. So that we are going to implement as part of this demo, and from there we'll move on, and again we'll implement two demos here for DNS to DB with Cloud SQL private IP, with LB self-signed SSL, or with Cloud DNS with cloud domains. So with self-signed SSL, for the students who doesn't have the registered domains, they can use this, and here again the communication is going to be private. These VM instances are going to access the private IP of the Cloud SQL database, and here we are using the self-signed SSL, and here you will see you will be using the prod grade SSL in this. So in this demo, wherein Cloud SQL private IP and LB prod grade SSL with Cloud DNS, and again this communication is going to be private. So once these things are done, we are going to learn about Terraform modules. So when we are learning Terraform modules, in one demo we are going to focus on using the publicly available modules on the Terraform registry, and once that is completed, we'll also build a custom module which is called the child module. So we'll implement a simple module which is a VM instance module, and call that VM instance module in the root module, and learn thoroughly about Terraform modules concept. And once that is done, we'll go on and then implement GCP DevOps for Terraform configs, and this is going to be close to a 70-minute session, and it is done in a very step-by-step manner, wherein we are going to create multiple branches here, example dev branch, prod branch, feature branch, and we are going to ensure that we are going to implement a GitOps style implementation. So wherein when you want to make a change to your environment, right? So you will create a feature branch and verify with the feature branch, and then merge those changes to the dev branch, and immediately your build process will trigger to apply those changes to the dev. And after that, this dev branch you will merge with the prod branch using the create, pull request and merge options in GitHub, and immediately a build process will be triggered, and once you approve that build, those changes will be applied in your prod environment also. So this is going to be a very interesting demo, and you are going to enjoy it. I hope you will enjoy it. Once this is done, so we'll move on to implementing GCP Global Application Load Balancer demo. So here we are going to focus on creating a global application load balancer which will load balance the traffic to multiple regions. So here we have used two regions, US Central one and Asia South one. So when you access from the nearest regions of US Central one, the request will be sent to US Central one app one, and when you access from Asia South one or nearest regions from Asia South one, request will be sent to Asia South one app one MIG. So these things we are going to test as part of this demo. So this completes the introduction about this course. Let's go ahead and then practically implement it. I'll see you in the next lecture. Until then, bye bye. Thank you.